today I will do a short intro of our app and especially why we are using the JavaScript core framework. So a little bit about myself. I started Power around 3 years ago, and before I was an iOS developer. I was working on a game, on few games, but using UIKit only. And after I started to work on macOS, but that was mostly for Power itself. I also I've done a little bit of Python, Django, and now doing some front end with React, just starting, but it's kind of interesting. You have my Twitter here if you guys are interested. So POW, I know some of you guys at Rambler are using it. We have a few people part of the team here today. So so I wanted to give a little bit of background why I've started to work on POW. So when I was developing iOS apps, I was doing some part of the server and some part of the iOS client. And I realized that all the time I was going back and forth to implement the APIs and find bugs on the server and try again. And every time I needed to run the app, go to the specific controller, test, etc., etc. And it was very painful. There was a few other clients, but all very basic. None of them had a very good UI back then. So that's why I started POW as a very simple app at the beginning. It looked like this when it started. So very simple. It was started on macOS Lion, I think. And so it was very simple, but very focusing on the UI, the ability to save requests, so you can test again and again. So now today, POW looks like this, a little bit more modern. But what's interesting in our UI today is that you may see the left here, the list of the requests you can try. You can compose the request here, and on the right you have the result, response, etc. But what we have in special is some parts of the UI are just integrated here, but they're actually extensions. So it seamlessly blends into the interface, but this part here is rendered as JavaScript. So these are code generators. In this example, we go pull the data you have entered visually in the UI, and we generate ready-to-go Swift code with an SQL session for you. We also have what we call dynamic values, these little popovers that let you compute values on the go. And many of them are actually also implemented in JavaScript. So while the user interface here is plain native interface, the code that runs to compute, here it's a awk token, all this stuff is in JavaScript. So how did it start? One day we had the people at API Blueprint, which is an API description format like Swagger or RAML. They contacted us saying we'd love to have an import and export of API Blueprint for POW. And we were thinking, that's really great, but if API Blueprint wants an integration, then Swagger will ask one, RAML will ask one, other people will ask some custom things. So we had the choice of either build ourselves or partnering with them to build that every time something new, or expose an API so we could tell people, you know, here is our API, here is the documentation, you can build it yourself, and we will help you, but you can use the API we expose. So that's why today I want to show you how you can make your app and how we have made POW an hackable tool using JavaScript core. So there are a few advantages to do an app with extensions. First of all, it will allow you to keep your app small. and clean. If every time a user asks you a new feature, you will implement the feature, add more code. You will need to hack some parts of your app to let people do what people ask you. And more, you will feel like your code is just a pile of different hacks you added for this use case or this use case. The API lets you instead focus on the features that make your app great for almost everyone. And then you can open source some of the custom behaviors users wanted as extensions and distribute them. The fact that you make it open source will, I think, allow you as a company to be more open. You will make sure your code is clean enough so it can be put on GitHub without any shame. And it also allows your users to come read the code, take inspiration for their own extensions. Every piece of code you will put on GitHub will be a model, a template for new extensions. And in the end, if people find bugs, they are free to go fix these bugs. The other big thing is now that we have many extensions, I think we have over 50 or 60 extensions today. Every time we find a bug, we can just ship this bug a lot more easily than what we've done. Like the upgrade process on the App Store, either iOS App Store or Mac App Store, is a pain. Apple used to take days to review the apps. But with extensions, we completely bypass the App Store or whatever review process we have, because we can ship new JavaScript code without changing the binary itself. So when we started to think about making extensions, we had the choice between different languages. Sublime is built with Python, and people can write custom modules for Sublime using Python. CocoaScript is another alternative. It's used by Sketch to implement Sketch plugins, as they call them. It's a mix of JavaScript syntax with Objective-C syntax with JavaScript runtime. So it's, as you can see, the syntax is a little bit weird. It's a mix of JS and Objective-C. And it also gives access to all the native APIs to the extensions. That's something we didn't want, because we wanted to keep our code, the code of the extension sandboxed and only give access to some features. So we went for JavaScript, mostly because it's the language that everyone almost can hack with. It's a very popular language. We may hate it or like it, but lots of people know it. And it has a very nice bindings with native code. In the end, it's like V8 for Chrome. It's JavaScriptCore is the engine of Safari and WebKit. So going back to how you can define an API for your application, a JavaScript API for an application, I think the fact that you describe an API and you let your user use it forces you to create a clear limit between what's supported and what's not. You have an interface contract, which allows you to have very strong testing on your side. You can know if your API behaves as you have documented it. And because you'll be very likely to use your own API to ship new features as extensions, as we do, you will find yourself, if your API is convenient enough to use, or if you made some super complex API no one wants to try. So an example of JavaScript bindings with native code, something very easy. Here we have this NS string that describes the math power function, so 2 power 30 in JavaScript. And we will simply call evaluate script on this JavaScript code. And we will end up with a JavaScript value. And after easily, we can convert this value to a number. We'll get a NS number, and after simply get an integer for it. And we see the result here. So my example, 2 2 power 30 is the equivalent of 1 gigabyte. And we've just run that math operation in JavaScript from inside the native code. So that's very easy. Just with 3 lines here, we've been able to create a JavaScript context, run some JavaScript, very tiny JavaScript inside this context, and convert back the number we have in JavaScript back to a native C or Objective-C integer. So all the values you have in JavaScript are automatically bridged for you to native types in C, an Objective-C or Swift. So for example, a JavaScript string becomes an NS string, a number will become NS number, date, NS date, etc. The JavaScript context, just in the slide before I had JS context, is a container where all the values we have in JavaScript, that can be classes, functions, they will all be stored inside a context. The context is tied to the JavaScript virtual machine that evaluates all the JavaScript code behind. And contexts are single-threaded. Unlike Node.js or web browsers, you have only one thread. That means if you want to have your app be multi-threaded for performance reasons, you will have to handle yourself the thread safety. So the way we do it in Pow, we have multiple threads, and we just run things in the background and bring back the values to the main thread when the execution completes. For the custom objects you may have in your native code, if you want to bridge them to JavaScript, there is a convenient protocol, JS export, that lets you bridge native classes to JS prototypes, and obviously the instances to JS objects. So a little example here. In Pow, we have the HTTP requests, we represent as LM request. And we want to define some methods, getters and setters, for the JavaScript API. So what we do is we define an Objective-C protocol that derives from this JS export protocol that is in the JavaScript core framework. And we can define each of the methods we want to have. For example, here we have get HTTP method, get URL, and setters. For each JavaScript method, we will bind it to a native Objective-C method. And once we have defined this magic protocol here, we simply need to create a class or a category that implements the methods that this protocol exposes. So now I want to do a little demo for JavaScript. Cool. So I created a Swift playground here. And the goal is to draw a chart using JavaScript. So here I have a UI view subclass that basically takes a function, a closure, as a property, a Swift closure, and will draw for all X values, we'll draw a Y. So here you have all the implementation details, draw the axis, the plot values, and the points. And here I create my view, and if we look at the preview, we have a line drawn to the screen. So the closure I have here in Swift simply takes X value and return 2x plus 1. Something very easy. But I want to modify this code to give a way to run JavaScript instead. So the first step is to define JavaScript context. Yeah, okay, thank you. So once we have a JS context, we can define a JS closure of just a function. So for that, we just evaluate. Thank you. Evaluate a JavaScript script, and here I can define my JS code. So I will keep it very easy for now, and I will simply have a JavaScript function that takes x and returns x. So basically drawing a line. And from inside the Swift closure here, I will create a JavaScript value that will contain the x I have here as a double. We'll call it value x, and we'll do JS value. We instantiate a new value. You have a lot of convenience initializers here. Here we'll take a double x, and we need to pass the JavaScript context here. And now that we have this value here, we can simply evaluate the function fn we defined before, the JavaScript function, and we will call on it. We'll call this JavaScript function from our native code in Swift. So here we should have here the value returned as a JS value. So we'll call it value y. And now that we have a value y, I can explicitly cast it to JS value. Now we'll take a integer, so more likely a double. So I got a NS number. So I convert explicitly the JS value to NS number, and now I can take double value from it and return. Let's see what we have. So it seems like one issue we have with this JS API, the JS context API, is that they didn't define well the nullability constraints in Swift. So we need to have explicit unwrapping. Someone continue? Why? Oh, this one? No, this.
There is an open bracket, and there is no the close.
Oh, I forgot that?
I mean, in a JavaScript code.
Oh, okay. Thank you. Perfect. Thank you. And now, yeah. Now we have our JavaScript code. So for each, thank you. So for each x value we have running here, we are evaluating the y value within JavaScript, and we can display that as Swift code. So let's go and pick one of the nice math functions I have here, written in JS. And I will paste that in our code instead of just one axis. Running this again, and now we have something nice. And what's interesting here is all the points are calculated from JavaScript. So we are calling over 1,000 times JavaScript, going back and forth from Swift to JavaScript, and that works perfectly. We still have native drawing, native UI views, but in the backend, all the heavy lifting is done in JavaScript, and you could do anything you want with that. So that's it for the demo. Cool. So one thing to mention here is that you are not on the web. This is JavaScript, but things you will have on the web, like WebSockets, set timeouts, DOM manipulations, Ajax, web workers, web crypto, you name it. Everything you have on the web won't be here. You'll have pure vanilla JS. This means you have this JS spec row, and all the things you have on the web is completely different. It's if you can think of Node and the web, and you have the minimum set of features. But this is not only bad. This also gives you some safety. The fact that Ajax is not here means you can be sure that your JavaScript extensions won't have access to the network. So what we are doing inside of POW, we are actually multi-threading JavaScript. In fact, the app is using core data and Grand Central Dispatch, and that works perfectly with it. We have multi-threaded core data with private queues, and we can easily run one JavaScript context for each private queue, and that works nicely. Grand Central Dispatch also makes it easy for us to have JavaScript call between multiple threads, but make sure we'll never use the same context at the same time between two threads. So as I mentioned, you don't have set timeout in the JavaScript core, but you can easily implement that using GCD with simply a dispatch queue and run something after a timeout, and that works pretty well if you are sure of your multi-threading constraint. So quickly, I want to give some examples of the extensions we have in POW. We have three kinds: the code generators, as I showed before, that generate client code or anything, importers, and dynamic values. So the code generators can generate Swift code, Objective-C, Python, Ruby. We have a long list on the website, PHP and other stuff. We also generate code for command lines like curl or HTTP. It integrates with API descriptions. Blueprint, Swagger, Ramble can generate full descriptions from your old document, not only from some snippets for one request. Also supports export to third-party apps like Postman. We also have, on the other side, importers. So you may be aware of HTTP archives, HAR. From the Chrome console, you can export a batch of Ajax requests as HAR, and we can import that with POW. On the same side, API descriptions can be imported. Same for stuff like Postman. And in the end, we have dynamic values that lets you do some inline computations inside your requests. We have auth stuff like JSON Web Tokens, digest. We have something for Django. We can integrate to third-party services like Amazon. We have for Amazon SigV4. Auth0 is a service for authentication. And also nice for the randomizers. We can generate UUIDs. The talk just before was about JSON schema, and that's really a great chance because we integrate nicely with JSON schema. You can fake JSON schemas. Just putting a schema inside POW will automatically generate values that match to that schema, but will be just stub values. So who uses JavaScript Core? So obviously Safari and apps like us, but also a framework, React on the native code. React Native doesn't use at all the web views, but instead uses JavaScript Core as pure JS. So why would you use JavaScript Core in your apps? In the end, it's actually pretty cool. You can open source a lot of your code, make it public. This way, we always have an answer to the user. If someone asks on Stack Overflow, oh, I have this very custom behavior, I want to do this and this and this, we can a lot more easily tell them, you can write an extension for that. That's not something we're going to support in the app, but extensions will be here. And it allows us to be a lot more featureful than the competitors we have. The nice thing is now we are a team of 6, and we have one person. Jonathan is spending all his time on the extensions, and that means multiple times a week he's shipping updates to the extensions. That's not something we could be able to do in the app. People will be just bothered to update all the time. But for the extension, that's just seamless. We ship code all the time, and that's a huge benefit for us. Thank you very much. You have some contact here if you want to see our website, or any question on Twitter will work. Thanks.
Спасибо, Миша. Друзья, если у кого-то есть вопросы на английском, на русском, Катя, вот там человек. Вопрос на английском или на русском?
Я попытаюсь на английском.
Okay.
Hi, Misha. Thank you for brilliant presentation.
Thank you.
I'm just curious. JavaScriptCore. What version of ECMAScript does it use? 5, 6?
So that's the question is what version of ECMAScript is using JavaScriptCore.
Yeah,
so that heavily depends on the version of your OS. JavaScriptCore is supposed to be almost the same version as Safari you have. When you update Safari, they ask you to restart your Mac, and the reason is because they are changing the framework behind. But we have noticed some differences, like sometimes Safari is newer than the JavaScriptCore they give us. Currently on El Capitan, ES6 is not so much supported, like classes are not here. On Sierra, there have been some updates. We have classes, static properties, more stuff are supported. But most of the time you can use caniuse.com, and if you look at Safari, you should have almost the same. So now we are, I guess, maybe Matt can answer more than me. I think on Sierra it's almost ES6 compliant.
You can always use Babel.
Yeah, and you can, that's something we do on the extensions. To be safe, we use Babel, and Babel compiles back to.
Fine, thank you.
Коллеги, вопросы?
Misha, thank you for your speech. I have two questions to ask. The first one, I really want to know some words about performance. If you run complex things written in JavaScript, will it affect performance?
So that's exactly why we. So I'll just repeat the question maybe for the video and stuff. So the question is, how performant is JavaScript Core, and does it affect the performance of our app? We always run JavaScript on the background thread, except some edge cases when you do a copy paste. We need to, if the result of the copy paste is coming from JavaScript, we need to do that synchronously on the main thread. But otherwise, it's all the time on the background thread. It's actually quite good, I think. We don't have many performance issues. To be honest, the one we have now is the fact that we load massive files that Babel made, and just the loading time takes performance. So if you can cache the JavaScript context, so every time you don't need to load and parse the file, you can just run the code. I think in this case it's quite good.
Thank you. And you have open extensions. I can download it from your site. Are you moderating it some way?
So the question
you have code generators.
Okay. So do we moderate the questions we have on do we moderate the
code generators and
extensions we have on the website? We do actually. We every time someone makes an extension, they ask us, they tweet us or send us an email to add the extensions to the repository. We quickly look over the code because extensions could actually grab tokens or private keys and send them to the network. So we want to be a little bit safe. So yeah, we do. But if you have an extension you want to use internally in a company, you can always build that and distribute as a zip file to others. No need to go to our website to make and run an extension. So in this case, you can distribute it outside of our website.
Еще вопрос оттуда. Что-то тот парень был первый. Давайте тоже, поскольку у нас немножко ограниченное время выступления, еще один вопрос. И я напоминаю, что вот здесь вот справа от вас есть стенд, где Миша и его коллеги могут ответить на любые ваши вопросы, там, возможно, поделиться какими-то подарками. Впервые на Rambler.iOS есть стенд какой-то компании, это очень здорово. Вот, соответственно, в перерыве, после конференции подходите, вот, и опять же на afterparty, я думаю, что ребята будут с нами, я надеюсь. И last question.
Thank you for your presentation. As I know, if you want to sell your app from with App Store, iOS App Store, you can't use this solution. You can't have dynamic parts of your app or such ways. Am I right, or were some updates?
So the question was, if you ship your app on the App Store, you cannot have dynamic code running JavaScript. Actually, lots of apps are running JavaScript on the App Store, and Apple doesn't have a problem with that. We are not on the Mac App Store anymore, but we have been with extensions on the Mac App Store for almost 2 years, I think, and Apple is fine with that. I think as long as you don't have some core features of your app, you completely change the UI across updates without shipping a proper update. Apple will be angry, but otherwise, if you keep just as clearly extensions, I think they won't have any problem. The other example, as I mentioned before, we have React Native apps are running JavaScript Core with JS files, and like lots of apps, including Facebook, is shipping the extensions with. They are shipping React Native using JavaScript Core, and so they are running JavaScript on the apps, so they are fine. What Apple doesn't like is if you ship your own JavaScript runtime and execute JavaScript, but they force you to use JavaScript Core. Otherwise, it's okay.
Okay, thank you again.
Thank you very much.